Okay. The last unit is using trig identities to solve equations. We know how to manipulate identities, and we know how to solve equations. We're gonna put this together, and this is just a very like a basic part. As we get more identities, we're gonna be able to solve different types of equations. So let's start with the first one. So 4 sine of theta equals the tangent of theta, and we're gonna let theta between 0 and 2 pi. So you look at this and you say, the first rule I told you before was try to get everything in terms of sine and cosine. So we're going to turn tangent use the identity sine theta over cosine theta. So I want to get everything out of the denominator. So I know I have 4 sine theta, cosine theta, and I'm going to set everything equal to 0. I don't want to cancel things out. I'm not comfortable with canceling in most cases. Obviously, there's exceptions. So you know what? Let's get that sign over to the left, set this equal to 0, and we're able to factor out a sine, and that leaves us with 4 cosine theta minus 1 equals 0. We have 2 equations, sine of theta equals 0, and cosine of theta is equal to 1/4. Obviously, this is a calculator problem. If they just ask for the cosine, you're done. But if they want exact answers, this will be on part 2, obviously. Let's just see here. This part, this is 0, pi, and 2 pi. What's going on over here? You use your calculator, inverse cosine. Inverse cosine of 1/4. And then the answer is 1.32. Now, you also would say, hey, Mr. Adler, cosine is positive in the first and the fourth. So I need a reference angle, that's 1.32. Just subtract that from 2 pi. Just visually see that in your head. Here's theta, and here's theta also. So this is pi, this is, this rotation is 2 pi minus theta. Okay, but once again, we replace tangent with sine over cosine. Let's try another problem. This one is going to be a quadratic. The equation is 2 sine squared minus 3 cosine theta equals 3. Now, yes, everything's sine and cosine, but we know from our experience in the other units when we want to do these type of equations that look like quadratics, we want to substitute the same variable, and sine and cosine, they're a little different. So whenever you have a quadratic, we want every single trig to be the same. So you say, okay, well, you know that sine squared of theta is 1 minus cosine squared of theta. So that's the identity we'll be using to replace sine squared, so all the terms are cosine. So 2 times 1 minus, I'm going to be a little lazy here, it's cosine squared minus 3 cosine equals 3. Okay, let's fix this up. We want a nice quadratic. I'm going to tell you 2 things. I'm going to distribute the 2. I'm going to bring that 3 over, and I'm going to multiply everything by -1 because I want a positive coefficient for my c squared. So I have, let's see. I have negative 2c squared minus 3c. What do I have here? Minus 1 equals 0. Let's move 2c squared plus 3c plus 1 equals 0. If this is part 1, you'll be able to factor it. If it's on part 2, it's probably not factorable, but I'm not going to really dwell on that. That's a basic GDC. This is basically solving a quadratic in the GDC. But instead of c, it's actually cosine. So we have 2 cosine theta plus 1 cosine theta plus 1. So once again, it would be a regular quadratic with c, but it's not really c, it's cosine. So we have cosine of theta equals -1/2, and cosine of theta equals -1. Please make sure none of these values are greater than 1 or less than -1. We eliminate it. And so let's see what's going on here. Well, I know that the cosine of 60 is 1/2, or pi over 3, but it's negative, so in the second and the third quadrant, so that's 120 and 240. So 120 is 2 pi over 3, and 240 is 4 pi over 3. And then the last answer, where's the cosine equal to -1? That's at pi. So here's your solutions to the equations. Obviously, you can see some of these might, in the case you might need a GDC, but the idea is you immediately recognize this. Also, if it's part 2, GDC. So I'm going to give you specific ones where you don't really have to use the GDC, but you can try them on your own. As Steve is coming on, good luck.